Hello everyone, and welcome to the MLOps workshop. So over the past few videos, we've discussed the importance of model packaging, what it is, what it looks like, and a few tools to accomplish model packaging like MLflow and ONNX. So now that we've covered packaging, it's time to start looking at serving these models. So in this notebook, I'll walk through the example model that I'll be using for both serving and containerizing. It's just a simple iris model, and we'll also be packaging that model up in a slightly different way than what we've seen before in this notebook. It's a little easier of an approach. So, all right, let's get started. So let's install our package requirements. We're going to mount our Google Drive so that we can save our model directly in our Google Drive after this. We're going to quickly download a iris dataset CSV, which we'll see that will show up here on the left. Perfect. Just so you know, if you're not familiar with Google Colab, this file explorer over here on the left, we can get there through /content. This G drive, so this is where we've mounted our data. So inside of here, this is going to be all of the data inside of your Google Drive. But anything outside of it, like this iris.csv or sample data, if you restart the kernel or you restart the Google Colab session, these won't persist. They'll disappear. So just so you know, if you want to save something to the Google Drive for downloading it to your local machine or using it later, you'll have to save it directly to your Google Drive and not just this /content area. But we don't really need this iris data set, so it'll just be stored in this temporary file system. So we're going to import CSV into a pandas data frame. We can see just the standard iris data set. So here we're creating a pre-processing label encoder for the strings over here. This is a good example for a data artifact that we're going to want to also use at inference time. So it serves as a good example for packaging up pre-processing data artifacts with the model itself. So we can see there's no more strings, it's all integers. All right, we're going to generate our train test split. Okay, and here we've seen this once before. It's just the standard IrisNet MLP model. I believe we use this in the serializing and deserializing notebook. So we're going to initialize our model and train it. Okay, cool. We'll do a quick inference check, and we get Setosa. Great. So now, at this point, you have to start thinking about, what data artifacts do I want to serialize to disk and package up with our model. So two things that come to mind. One, which I previously talked about, the label encoder, because we will need that at inference time to distinguish between the model prediction, which will be an integer, and we need to convert that back to the string, the actual class name, for instance, Setosa. And we'll also want to persist out the state dict. So let's start with the label encoder. So here we can see /content label encoder. Again, this is just in the temporary file system, so we can see it appears there. Now we're going to save our state dict. We can see that shows up there. Great. And if we do a quick ls, we can see this matches what we're seeing in the UI. Okay, so here's the slightly different approach to model or packaging a model with MLflow than what we've seen before. So basically we're going to be creating this artifacts object, and inside of this artifacts we're going to store the file path to all of the data artifacts that we want to package up with our model. Right? It's pretty straightforward. So like I previously mentioned, we have a state dict and we have a label encoder. And here we're passing the path to both of those, which is over here, the /content /name of the artifact. And here we have a class model wrapper. And this is inheriting from the MLflow.python model. So inside of this, we're going to define two methods, load context and predict. So load context, pretty straightforward. It's going to have this context object. This is provided by the Python model from MLflow, and basically what's on this is all of our artifacts will be located on this context object. So if we're loading this in an inference environment, everything that we specified up here, we will have access to in this load context. So here we can see we're loading in our model. We're going to load the state dict from context.artifacts.state, or accessing the key state dict. And we also have access to context.artifact label encoder. So we're also going to load in our label encoder, set those to self.model and self.label encoder. And we're also going to define a predict method. Just like using the previous MLflow process of using the pyfunc methodology, we defined a predict method there as well in one of the previous videos, and that took in a pandas data frame, and this will be very similar. So we're going to define this predict method, and it'll have a context object and model input. So the model input will be whatever you pass to the predict function off of the model. And here we can see we're just taking the model input.values. This is just, you can call this on a pandas data frame to get the values from inside of it, converting it to a torch tensor, calling, conducting inference on the model, and then getting torch.argmax, and then just getting the labels. So we can see self.labelEncoder.inverse transform. This is because we loaded in the label encoder in the load context method. So before I go any further, you'll see we have this from model import IrisNet. We don't have a model module here. So why do I have this? If we go back up to where we define the model, basically notebooks are great for experimenting and getting out ideas and iterating quickly, but it can be challenging at times to then take that logic out of the important logic out of the notebook and separate it out into a more formal project structure. So what we're going to do here is instead of so when we serialize our model state dict out and we want to load that back in, we still need we need an instance of this class. So when we need this class to be packaged with the model itself. So the best way to do that is to pull it out into its own file. And in all honesty, I think that's just probably best practices anyways. You don't really want a model just living inside of a notebook. So let's go over to the left here, right click and do new file. Here we're going to do model.py. Let's double click. And we're going to paste in, so expand this window a little. Here we're pasting in just, we copy and pasted this, our IrisNet, and let's do from model import IrisNet, and we'll also have to include our torch requirements. I don't think we need Optum in here, so let's do that. And then if we go back down, did I pass it? Yes, I did. So if we run this now, we can see it succeeded. And now, since we have this in a separate file altogether, we can tell MLflow to package this whole file up with our serialized weights and everything else. And that way we can load this back in at inference time. So that's why we have access to this from model import IrisNet. Basically at load time, MLflow will make sure that this model.py file gets loaded into this same context that we're importing from. So we also need to specify the environment that we created this model in. That way we can replicate it at inference time. So if we run mlflow.pyfunc.get default conda env, we can see this is the default conda environment that comes with MLflow. We have Python, and then we have pip level requirements, which are MLflow and Cloud Pickle. So you'll notice we don't have torch in there. So In a previous method, we used a YAML file that we had on the left here. You can also define these Conda environments using a dictionary in line, which is great. So we can see, just like above, we have channels default, dependencies, we're going to have Python, Torch, we're going to set it to whatever Torch version we're using in this notebook, sklearn for our label encoder, and our pip requirements. We're going to have MLflow and CloudPickle. CloudPickle is used by MLflow for serializing and deserializing data artifacts. So, all right, so let's run this. We did that, and let's run this. Okay, great. So what do we have here? Now we have, let's close this out to give us some more room. Now we have a MLflow Python model path. This is going to be saving directly to our Google Drive. And here we have, this should look familiar, MLflow.python.save model. So we're passing in a model here, or the path that we want the model to be saved at, the Python model, which is going to be our model wrapper. This is what we defined up here. And our artifacts, remember we defined those up here, as well as our Conda environment, which was defined right here. And this last section, code path, here's going to take in a list of any code-related dependencies. So here we have content/model, right? This was our model that we created over here. We want this to be packaged as well. And we also should probably include some metadata. So what do I mean by metadata? Let's create a new file here. And let's call it metadata.txt. And now that we have our metadata file, let's go ahead and double click, open it up. And here we can provide, basic level information or details about our model. So for instance, we might want to include a version attached with this package, right? That's a great idea. You might want a brief description of what the model is, and maybe you want to define the inputs that the model takes, right? This, we'll see how this metadata.txt, it seems like a simple thing right now, but we can see how this can be useful in the serving layer. So we now have metadata.txt in our temporary file system. So that's what we're passing in the code path, model and metadata. Let's go ahead and run this. Great. And now let's quickly test loading this back in. So just to make sure everything was saved properly. So we're importing pandas here because, like I mentioned, this predict function expects it doesn't need to be a pandas data frame, but it's kind of best practices to have that, have your input formatted in that way. So here we're loading our model back in, calling python.loadModel, passing in MLflow Python model path. This is the same path we saved it to disk. And then we're just going to call loaded model.predict, and we're going to pass in our data frame with I think this is a Setosa example from the train test. And there we get our predicted label back. Okay, so this is going to be the model that we're going to be using for the remainder of the workshop in both the serving and the containerization sections.